Okay, so let's start today's session. Unit number 2, lattice theory. And in this topic, in the last lab, was discussed few definitions related to this topic: power set, product set, and then after definition of relation, types of the relation, four types there: reflexive, symmetric, anti-symmetric, transitive. And after that, we define one universal form of the relation, that is called equivalence relation. And in definitions, when we say the relation is equivalence, if it is satisfied the three types of relation, means reflexive, symmetric, and transitive, then it is called equivalence relation. And based on this theory, we'll solve some few examples related to this concept, how we can check the given relation is equivalence or not. Okay, so this example 1, 2, and then after we solve a few examples related to this topic, third one, fourth, okay, in the last lab, let's study. Now next, today we'll discuss the next theory of this unit, that is known as a partially ordered set. And it is similar to the equivalence relation, but the one condition is changed that. So which conditions we consider for the partially ordered set? If R is a relation on set A, and if R is a reflexive, antisymmetric, and transitive, okay. In the equivalence relations, you have to check that reflexive, symmetric, and transitive. But in place of symmetric, we'll check the antisymmetric condition. And remaining two as it is, that it is reflexive, and after antisymmetric, and then the transitive on relation A. Then AR means it is notations for that. A is a given set and R is a relation. Then bracket AR, it is called the partially ordered set, and it is simply denoted by we can say it is a PO set. Okay, partially ordered set. PO set means partially ordered set. So three conditions we'll check to verify it is a partially ordered set or not. The first is reflexive, that we already know that how we can check the reflexive conditions. Then after antisymmetric, what is the condition of antisymmetric? For AB belongs to R, okay, for any AB belongs to A. If the relations AB belongs to R, then BA means its symmetric form should not exist again the R. So that is condition of antisymmetric case. So we'll use it to verify the partially ordered set or not. And then third one is transitive. For AB belongs to R, BC belongs to R, then based on these two relations, we'll check AC should also belong to the R. So it is a transitive condition. So that is called the PO set, and there is one notations for that. This bracket we'll use to any example that AR, okay, this bracket AR. So what is meaning of this bracket? We will check the partially ordered set or not. Okay, this A is a given set there, N, Z, Q, R, any one set is a given that. R is relations to the number which include in the given set. So R may be anyone that here lots of relations we can consider to define any example, to create any example. So that is the notations for that. We will denote the partially ordered set as a AR. Okay. And now let us consider one example for the A is equal to ABC, three number include in this set A. And now I'll consider one subset of the A cross A. Okay, you can also create A cross A if it is required to define the subset of A cross A. And if you can write directly it here, so just consider one example directly, a subset of A cross A, and that is the relations. And now we'll say it is a partially ordered set or not. Means we'll check that the relation should be reflexive, the first condition. Second condition, it should be antisymmetric, and the third condition, it should be the transitive. If these three conditions satisfy for the given relation, then we'll say this relations is known as the partially ordered set. So here the 6 pair is mentioned in this subset, and let us check first it is reflexive or not. The condition of reflexive means for every A belongs to A, the relations A comma A should belongs to the R. Okay, means A R A should exist in the given subset. So here A comma is exist, B comma B is also exist, and C comma C is also exist, because there is a three pair, three value, three object in the given set A. Then we'll consider for every A belongs to A, for every object belongs to the given set, the A comma A should belong to the R. So here A comma A belongs to R, B comma B belongs to R, and the C comma C is also exists there. So this relations, this subset is satisfy the reflexive relation. Okay, so it is a reflexive relation on the A. Now second one, antisymmetric. So what is meaning of antisymmetric? If AB belongs to R, it implies its symmetric form BA should not belongs to the R. Okay, that is called antisymmetric case. In symmetric form, we'll observe its symmetric form belongs to R, but here its symmetric form does not belongs to the R. Means AB belongs to R, then BA should not exist, should not belongs to the R. So here consider for each pair AB. So here B comma A is not exist. Okay, you can check this remaining 5 pair. It is not here B comma A. Okay, and second one is B comma B. So as we know that A comma A, B comma B, C comma C, this pair is by default a symmetric as well as anti-symmetric case. Okay, if you have to verify it is a symmetric case, then we consider B comma B, A comma A, C comma C, that is a symmetric pair. But if we have to check the anti-symmetric case, so we'll also consider this 3 pair. Okay, means B comma B, A comma A, and C comma C are the example of anti-symmetric relation. Then after A comma C, so here C comma A is not mentioned. Okay, it is not exist that. Then fifth pair is a B comma C, so C comma B is not exist in the remaining 5 pair. Clear? And C comma C is by default anti-symmetric case. So here we have to verify all this pair. Its symmetric form is not exist here. What does it mean? If for AB belongs to R, B comma A does not exist, does not belongs to R. So what is that? That is called anti-symmetric relation. Okay, the second one. And now the third one, a transitive. So how we can check the transitive relations? If for AB belongs to R, BC belongs to R. Consider the B should be the common, that B should be the same, 1 comma 2 and 2 comma 5. Okay, 1 comma 3 and 3 comma 9. So this middle value should be the same. Then based on these two relations, we'll map the A comma C, and that also belongs to the R set. So let us define such pair where the B is the same there. AB and B comma B. Okay, the first one is A comma B and B comma B. So based on that two relations, we can map A comma B as a AC, and A comma B is also exists that. Okay, and then after you can consider B comma B. Okay, and then B comma C. So you will get a B comma C from this pair, and B comma C is also exists there. Then after you can consider A comma A and the A comma C, where A is a common that. So based on that, we'll get A comma C as a first value of the first set and the second value of the second set. So it map as a comma C, and that is also exists. Okay, and remaining you can consider A comma C and C comma C. So that we already define here. Then after you can consider, yes, that's all. That is the pair which you can consider as A comma B. AB belongs to R, BC belongs to R, and based on that we can easily check that A comma C is also exists in the given relation. So therefore we can say it is the transitive relation. So all these three relation is satisfied for this given subset as a R, and therefore we can say this relation is known as a partially ordered set. So here it is reflexive, that is antisymmetric, and that is a transitive. So we can say this AR. A is a given set. Here it is a ABC, and R is a relation, that is the one subset of A cross A. It is the partially ordered set. Okay. So here first we'll identify difference between equivalence relation and partially ordered set. In equivalence relations, we just consider relations which is satisfy the reflexive, symmetric, and transitive. And here we'll use the, in place of reflexive, we'll check the antisymmetric condition. If it is satisfy reflexive, antisymmetric, and transitive, then this form, these relations for the given set, it is known as a partially ordered set. Okay, in place of symmetric, the relations should satisfy the antisymmetric condition. Okay, and if it is satisfied for the given case, then this form, this given example is known as a partially ordered set. Okay, so it is simple one. Just check the reflexive, that already we know that how we can check the reflexive condition. Transitive, that is familiar with us. And the third one is there, antisymmetric. Okay, and the condition of antisymmetric is there, AB belongs to R, then BA should not belongs to the R. Now let us take one example. Data is there, AR, and A is here Z. Okay, A is equal to a Z, and R is equal to less than or equal to. This condition is given there. So Z means a set of integer which include the negative infinity to the positive infinity. Okay, this number will include in the Z. And now consider xy belongs to the Z. Okay, xy belongs to Z, any two number considered from the Z. Then you can consider xy belongs to R. Okay, xy belongs to R means these two number are exist in the relation if, what is the conditions for this two number? Okay, x should be less than or equal to a y. Okay, x r y means what is the R here? R is the less than or equal to condition is mentioned. Okay, so this is a relation is given in this example. Z R, what does it mean? Z is a given set which known as a negative infinity to positive infinity integer. And now what is meaning of this less than or equal to? Okay, let us consider two any number from the Z, and let us check this are in relation or not. Okay, means xy belongs to R if this two number means x and y should satisfy the condition. What is the condition here? X less than or equal to a y. Okay, so which number you can include in the R? You can include in the R which satisfy this condition. You can include the 1, 2. Okay, you can include the 2, 5. You can include the -3, 0. Okay, -3 is lower value comparison to the 0. Clear? Then after 3, 9. So this type of pair you can include, which is a x is a 3, y is a 9. So that is satisfy this condition x less than or equal to a 9. You can also include there a 1, 1. Why it is 1, 1 is also existed? Because here less than or equal to condition is mentioned. Less than or equal to. If I remove the equality and it is a strictly less than, then 1, 1 will not exist there. Okay. Here it is a 1 less than or equal to 1. Why it is a valid? Because the less than or equal is mentioned that in this condition. And if I remove this equality, it is only strictly less than 1 less than 1. So it is a not a true. Okay. And if I just consider this equality between them, now it is a true. Clear? So therefore 1, 1 is exists there, 2, 2 is also exists, 3, 3 is also exists, 0, 0 is also exists, -1, -1 that is also exists. Clear? So here we have to check it is a partially ordered set or not. So what is the first condition of partially ordered set? First condition is the reflexive condition. So for integer x, okay, because that is a set of integer here. And now for every x belongs to z, we'll check that x comma x belongs to R or not. Okay, we'll check this x comma x belongs to R or not. So how we can write x comma x? A relation is less than or equal to, so that you can write x less than or equal to x. Okay, and now choose any x from the z. This condition will map as a 1 less than or equal to 1, 2 less than or equal to 2, 3 less than or equal to 3. Okay, and that is a true form in mathematics because the equality is mentioned between these two numbers. Clear? So if I remove the equality, then it is not a reflexive relation. Okay, if I change the notations as a strictly less than, only less than that, then these reflexive conditions will not approve. So here x r x, that is a valid form, and therefore we can say less than or equal to is a reflexive relation on a z. Clear? The first condition is true, first condition is valid for this case. And now let us check the second one, or anti-symmetric. So how we can check the anti-symmetric conditions? What is this form? If AB belongs to R, here it is XY notation there. So let us use this. If XY belongs to R, this implies YX should not belongs to R. Clear? That is required to say it is anti-symmetric or not. Okay, XY belongs to R है, but YX उसका symmetric form R के अंदर नहीं होना चाहिए. Clear? So here for XY belongs to R. ठीक है? What does it mean? X less than or equal to Y. X less than or equal to Y. So for this two number X and Y, can we say always Y also less than or equal to X? That is a not true always. Why it is a not true? If I consider 2 and 5, okay, 2, 5, where you can say 2 less than or equal to 5, but it symmetric form, we cannot say 5 less than or equal to 2. Clear? That is a not true always. Okay, in which case it will be the true? For the reflexive example case, 1 less than or equal to 1, 2 less than or equal to 2, 3 less than or equal to 3. For this case it will be the true, but for all such possibility it never will be a true. Okay, so y can't be less than or equal to x. Clear? Y can't be less than or equal to x. So you can consider any example for that. Here I consider 2 and 5, so 2 less than or equal to 5. So we cannot say 5 is also less than or equal to 2. Clear? Here 3 less than or equal to 9. So 9 is not less than or equal to 3. Clear? So y can't be less than or equal to x. What is meaning of that? Y comma x is not belongs to R, and that is required to check to say it is anti-symmetric relation. Okay, so y can't be less than or equal to x for any two integer x not equal to y. If x less than or equal to y, then y can't be less than or equal to x. And what does it mean? So less than or equal to is anti-symmetric relation on a z. Clear? Y can't be less than or equal to x. So what does it mean? Y comma x does not belongs to R. Why it is does not belongs to R? Because it not satisfy the relation. Relation is here less than or equal to. So for xy belongs to R, yx is also belongs to R to say y comma x is belongs to R. But here it is y can't be less than x. So therefore y x does not belongs to R, and that is required to say it is anti-symmetric relation. Clear? So we'll say it is less than or equal to R is a anti-symmetric relation on a z. Okay, and now let us prove the third one. Third condition is that transitive form. So what is the condition of transitive? So for xy belongs to R, yz belongs to R, and we'll say that xz is also belongs to R. Okay, so xy belongs to R means x less than or equal to y, and yz belongs to R means y less than or equal to z. So now observe these two conditions to this result. Okay, these two result, x less than or equal to y and y less than or equal to z. So what does it mean? We can easily say that x is also less than or equal to z. Okay, x is also less than or equal to z. And you can consider one counter example for that. You can consider, let us say x is a 2, y is a 5, and z is a, let us say, 9. Okay, that is x, y, z. So 2 less than or equal to 5, that is x less than or equal to y. Okay, then after 5 less than or equal to 9, that is y less than or equal to z. So based on this number, we can easily say that 2 is also less than or equal to 9. Means x is also less than or equal to z. Clear? So that is valid for any case, which you can consider x less than xy belongs to R, yz belongs to R. Then based on this two relation, we can easily say that x comma z is also belongs to R. Therefore, it is a transitive relation on a z. So it is reflexive, it is antisymmetric, and it is a transitive. So we can say the z less than or equal to is known as a partially ordered set. Okay, z less than or equal to is called partially ordered a set. Clear? So that is example number 1 based on the definitions. It is a poset or not. So here we'll check reflexive, antisymmetric, and transitive, and they all conditions are satisfied here. So therefore we can say it is the set, means it is a partially ordered set. And now next is there is one result. Set Sn. What is meaning of Sn? Sn means a set of all divisor of n. Okay, Sn means a set of all divisor. So how we can find divisor? Okay, for this particular number, और किससे डिवाइड होता है, ठीक है, उसका आपको एक कलेक्शन बनाना. फॉर एग्जांपल यहाँ पे 12 है, ठीक है, 12 इज गिवन दैट. सो 12 इज डिवाइडेड बाय 1, ठीक है, 12 को आप 1 से डिवाइड कर सकते हो. 12 इज डिवाइडेड बाय अ 2, 12 इज डिवाइडेड बाय अ 3, 12 is divided by 4, and 12 divided by 6. 12 is not divided by 7. So we cannot include this number in the set. Okay. And then after 12 itself. So 1, 2, 3, 4, 6, 12. So this is called S12. Okay. And that is known as a Sn. Sn is the set of positive divisor of n. Set of positive divisor of n. Means you have to start with the 1, 2, 3, 4, 5, and so on. So by which number is given number divided. So it is 12 is given there. So 12 divided by 1, 2, 3, 4, 6, and 12. So this is called the divisor set. Okay, set of divisors. And let us consider another number S15. So which number are the divisor of S15? 1 itself. Then after 2 is not include here, 3. Okay, 15 by 3 is divided. Then after you can consider a 5, and then after you can consider 50. Okay, so this 4 number you can include in the S15, and these are the divisor of the 15. 1, 3, 5, 50. Clear? Let us use the another number as 11. Okay, and 11 is a prime number. So there are two factor only, 1, okay, and the 11 itself. Clear? Let us consider S9. So S9 will be 1, then after 3, okay, and the 9. Clear? So that is called S9. Then after you can consider S20. So what is answer of S20? That is the 1, 20 divided by 2, 20 divided by 4, 20 divided by 5. Okay, 1, 2, 4, 5. And then after directly 10 and the 20. Clear? So these are the divisor of S20. Clear? 1, 2, 4, 5, 10, and 20. So this is called the S12. And why we consider here Sn? Because it is required in the next example, and it condition. Which condition? Or divide condition. So D is the divide relation. We'll consider now D is one type of relation. Here it is a less than or equal to relation. So now we'll use the D is also the one type of relation. D is the divide relation. It means A divide B, and it is denoted as a D B. So what does it mean? Consider two number. AB belongs to the set which follow this relation. Means a divide relation. Clear? So what does it mean? I can consider this is S12, let us take, okay? This S12 is given that here, and let us check which A and B you can consider in the divide relation, okay? So I can consider a 1 divide 2, okay? That is true. 1 divided by 2 means A divide B, okay? 2 divide 6 means आप 6 को 2 से divide कर सकते हो, ठीक है? 2 divide 6 that, but we cannot write 2 divide 3. ओके वी कैन नॉट राइट 2 डिवाइड 3 हियर व्हाई बिकॉज 3 को आप 2 से डिवाइड नहीं कर सकते हो ठीक है देन आफ्टर यू कैन कंसीडर 3 डिवाइड 6 दैट इज वैलिड ओके यू कैन इजीली डिवाइड 6 by 3 then after 3 divide 12 that is also valid but you cannot write 4 divide a 6 okay that is not a true you cannot divide 6 by 4 there clear so check the two number from the given set which follow the divide relation. So this pair you can include in the relation. Okay, this A and B, A comma B, you can include in the relation. So this is one result that is also asked for 1 mark short case and 1 mark MCQ. Here derive the S15, derive the S9, derive the S25. Okay, derive the S20. So which is the following answer? Okay. And then after we'll consider D as the one types of relation that means the two number from the given set which follow the divide relation. Okay, A divide B, 2 divide 6, 5 divide 30, clear? 6 divide 30 and so on. Okay, so is it clear? This example and the result, and then after okay so next example is there. Check whether the n comma d is a partially ordered set or not, where d is the divide relation. Okay, d is the divide relation, and the set is given that natural number n is equal to 1, 2, 3, and so on. Okay, this is the set of natural value, and d is the divide relation. Okay, r is equal to here a d means a divide relation. So which number you can consider in the divide relations? It is set of natural number we have, and we'll use the AB belongs to the n. Okay, so AB belongs to R if A divide of B. Okay, AB belongs to R if A divide B. So which pair you can consider in the relation? You can consider in the relations 1 comma 2, 1 divide 2 that. Okay, and 2 divide 6 means 2 comma 6 you can consider. You can consider 3 comma 9. Okay, that is also valid. You can consider 4 comma 16, 4 divide 16 that. You can consider 4 by 4 means 4 comma 4. Okay, or 2 by 2 means 2 comma 2. Lots of possibility that you just include the natural value from the n and which follow the condition A divide B. So check the pair which the first number should be divided the second number. Okay, means 4 divide 4, 4 divide 16, 16 को आप 4 से divide कर सकते हो ठीक है. 2 divide 6, you can easily divide 6 by 2 that. 3 divide 9. Okay, so this pair you can include in the relation, and now we'll check this relation is coset or not. Okay, means we'll check it is reflexive, then after antisymmetric, and then third one is the transitive. So let us check the reflexive condition. For any x belongs to n, for any x belongs to n, you can write x is equal to 1 star x. So what is meaning of that? Here I consider x divide y. Okay, what does it mean? You can write y is equal to mx, where m is the belongs to the natural number. What does it mean? If I consider 2 divide 6, okay, here x is equal to 2, y is equal to 6. You can write 6 is equal to, you just create a 3, okay, which multiply by x, and you will get here a 6. So here this 3 is called the m, okay, which is belongs to the natural number. So you can write x divide y means you can consider this equation as a y is equal to mx, where m belongs to the natural number. Okay, if I consider 4 divide 16, so you can write 16 is equal to 4 into 4. Okay, means y is equal to mx, where m is equal to here a 4, that is belongs to the natural number. Clear? So this is a formation of x divide y. Y can be write as a m into x. Clear? And here for reflexive conditions, for every x belongs to n, we'll check that x comma x belongs to R or not. So what is meaning of x comma x? X divide x or not. Okay, and x can be write as a x divide x means you can easily write x is equal to 1 into x, because it follows the equations y is equal to mx, where m from the natural number and 1 is here also belongs to the n. Clear? And you can also check for any number belongs to the natural line. Okay, 1 divide 1, here x divide x means 1 divide 1, that is a true. 2 divide 2, it is also true. 3 divide 3 is 3, okay, it is a true. 4 divide 4, 5 divide 5, 9 divide 9, any number you can consider that you can easily divide by itself. So it is a true for any number belongs to natural line. Okay, and for equations form, you can also prove that x is equal to 1 star x. Okay, and what is meaning of that? Okay, you can consider x divide y as a y is equal to mx form. Okay, y is equal to mx, and here 1 belongs to n, so therefore x divide x, and therefore you can write b is a reflexive relation on n. Okay, D is a reflexive relation on n, means it is approved. And now second one, antisymmetric case. So let us prove the antisymmetric relation. And that you can easily check by using the division relations. If I consider 2 divide 4, okay, x divide y, then we cannot say 4 is also divide 2. Okay, means 4 can be divide 2 that. If I consider 3 divide 9, okay, then it is not true that 9 is also divide 3. Clear? Means if xy belongs to R, then yx does not belongs to R. Okay, xy belongs to R, then yx does not belongs to R. So that is where you can also say the antisymmetric case, but here I consider a formula based answer. Xy belongs to n, x not equal to y. If x divide y, then x divide y can be write as a y is equal to xz. Okay, otherwise you can write zx, that is both are similar. So y is equal to x into z, where z belongs to the n. Okay, you can consider another notation in place of that if it is familiar with x, y, z form and so on. You just consider a small m. Okay, x y is equal to m into x, where m belongs to the a natural number. Okay, so if y x divide y, if x divide y, then y can't be divide x. Okay, and you can consider a counter example for that. if x divide y means 4 divide 16. Okay, 4 divide 16. This implies 16 can't be divided of 4. ओके 16 है 4 को डिवाइड नहीं कर सकता, ठीक है, 4 है 16 को डिवाइड कर सकता है, बट इट रिवर्स फॉर्म इज नॉट अ ट्रू दैट. सो इफ 4 divides 16, then 16 does not divide of 4 there. Clear? So that is required to say it is antisymmetric or not. If xy belongs to R, then yx does not belongs to R. Okay, so therefore we can say if it is y can't be divide x, so what does it mean? Yx does not belongs to R. Okay, means y does not divide x. So D is the antisymmetric relation on M. Okay, so second is also valid conditions, reflexive, then after antisymmetric, and now third one is the transitive condition. So let us prove it the transitive or not. We'll consider the three number from the natural line x, y, z, and if x divide y means xy belongs to R, y dz means y comma z belongs to R, then based on these two conditions we'll say that x comma z also belongs to R, means x dz. Okay, so x dy, y dz, then y is equal to mx, z is equal to ny. Okay, y is equal to mx, z is equal to ny, where mn belongs to n. And for these two equations, we'll derive the new equations from this both. What we have here, y is equal to mx and z is equal to ny. Okay, equation 1 and equation number 2. So put the value of y in the equation number 2. What is the y here? Y is equal to mx. Okay, so just replace the m into x in place of a y in the second equation. So we get here z is equal to ny, that is a given. And now in place of y, we can put m into x. It will become n m x. Okay, so simply you can write m into n into x. Okay, the product of two number m into n into the x. So we get here z is equal to m into n into the x, m into n. So here we consider here m comma n belongs to n. Okay, m belongs to n and n is also belongs to n. So if we consider it product, okay, m into n, that also belongs to the n, that is also valid. If I consider the one number or 2 belongs to n, okay, it is a m, and a 9 belongs to n, that is a n. Okay, 9 belongs to n. What is it product? 2 into 9, and 2 into 9 is 18. Okay, and 18 is also belongs to n, that you can easily check. Clear? 18 is also belongs to the n. What does it mean? This product mn is also belongs to n, and here we get a relation z is equal to m into n into x. What does it mean? Okay, z comma x is also belongs to the n. Clear? Z comma x is also belongs to the n. And therefore you can say is a x dz. And therefore D is a transitive relation on n. Okay, and you can consider a counter example for that, or three number you can consider as a x, y, z, where let us consider a 2 divide 6, clear, and a 6 divide 12, clear. 2 divide 6 and 6 divide 12, that is x divide y, y divide z, that is a true. We can easily say that 2 is also divide 12. This is x divide as well. Let us consider another choice for x, y, z, 3, 9, and 18. Okay, so you can consider 3 divide 9, 9 divide 18. So you can easily say that 3 is also divide 18. Clear? Means x is also divide as z. So What does it mean? That is known as a transitive relation on a Z. Clear? That is known as a transitive relation on a Z. So it is reflexive, antisymmetric, and transitive. So we can say this relation means n comma d is called partially ordered set. Okay, it is called partial order set for a division relation. Clear? So is it clear? Is there any doubt in the definition in these two examples? Yes. Is there any doubt to anyone? Umesh, Ronak, Dwarkesh, Dhanraj, yes, Parth. Is it clear? Is there any doubt? Remaining student, is there any problem? Any doubt?
No, sir.
Okay, good. Okay, so it is a partially ordered set, and now next example is there. And here, in example number 3, 4, 5, and 6. Okay. The solution is not mentioned here, but let us solve it one by one, and you just take a screenshot for the solutions page for your reference. Otherwise, you can write down in your book each and every topic, okay, of the solution. Just 1 minute. First example is there. ZR is the poset where the condition of R is given that here for ARB, means for AB belong to Z. ARB is denoted as a if and only if A is equal to B raised to N for a positive integer N. A is equal to B raised to N for the positive integer N. To check that it is a partially ordered set or not. So let us prove it, and you can also reply your answer. Is it reflexive, antisymmetric, and transitive or not? So let us first check it is reflexive or not. condition is here. Okay, AB belongs to Z, and you can consider such pair as a AB belongs to R if A can be written as a B raised to n for the positive integer n. A can be written a B raised to n for the positive integer n. Clear? So Z means a set of integers which include the if and only if A can be written as a B raised to n. A can be written a B raised to n for n is positive integer. Okay, that is a notation of positive integer. N should be positive integer n. So which pair you can include in the R, where you can check A is equal to B raised to n form. So you can consider there 4, 2. Okay, A is equal to 4 and B is equal to 2. So I can write 4 is equal to 2 raised to 2. Clear? 4 can be written as a 2 raised to 2. A is equal to B raised to n. So I consider n as a 2 and 2 is the positive integer. Clear? So this pair you can include 4, 2. Clear? This pair you can include 4, 2. You can also include the 3, 9. Okay. Sorry, 9, 3. Just interchange that 9, 3. Why it is valid? Because it satisfies the condition 9 is equal to 3 square. Clear? Because we get one positive integer n, which satisfies the condition. Clear? So can I include the 5, 5 in the relation? Can I include the 5, 5? Is it valid? Yes. 5, 5. Okay. Can we include in the relation 5 and 5? Yes. Is it true? Can I include this pair in the relation? Ethel, what is the answer? Can we include the 5, 5? As I consider 4, 2 because it satisfies 4 is equal to 2 square. Okay, means A is equal to B raised to n. 9, 3 means I include 9 is equal to 3 square means A is equal to B raised to n. Clear? So can we include a 5, 5 in this relation? Janice, can we include? Nikhil, Vachan, Anand, can we include a 5, 5, 3, 3, 2, 2 in the relation? Yes, that is valid. Why it is valid? Because you can consider A is equal to B raised to n form. So A is here 5 and B is also 5. So 5 can be written as a 5 raised to 1. Clear? 5 can be written as a 5 raised to 1. Clear? Where 1 is a positive integer that. So we can also include the 3, 3, 1, 1, 6, 6, minus 3, minus 3, 0, 0. Clear? So what does it mean? It is the pair of reflexive form x, x, 6, 6, 9, 9, 1, 1, 0, 0. So all such pair, okay, where both the number is same, they are included in the relation. So we can say that this all such pair are the reflexive form that, so therefore this relation is satisfy the reflexive condition. Okay, this relation is satisfy the reflexive condition. For a 3 comma 3 you can write, okay, 3 is equal to 3 raised to 1. 3 is equal to 3 raised to 1. When you can include the 3 comma 3 belongs to R, if A can be write as a B raised to n. A can be write as a B raised to n, where n should be the positive integer. Means it should be the 1, 2, 3, 4, 5 and so on. It should be positive any integer there. So let us prove the first one. First condition is there. Reflexive. For every A belongs to Z, we'll check that A comma A belongs to R or not. So A comma A belongs to R means you can write A is equal to A raised to A is equal to A raised to N, okay? And you can consider N is equal to 1. A is equal to A raised to N, and that you can write as A is equal to A raised to 1 by putting N is equal to 1, and that is belongs to the natural number, means it is a positive integer, okay? That is a positive integer, and that is valid for all such A belongs to Z. So therefore we can say that A comma A belongs to R, okay? And therefore R is a reflexive relation on a Z. R is a reflexive relation on a Z, okay? So first condition is proved. Now let us prove the second one, that is the anti-symmetric, okay? Anti-symmetric condition. So condition is there, for AB belongs to R, this implies B comma A should not belongs to the R, okay? That is meaning of that, if AB belongs to R, then B comma A should not belongs to the R, okay? For A not equal to B case, A not equal to B, if AB belongs to R, then B comma A should not belongs to R. So let us check it is anti-symmetric or not. So here we have AB belongs to R, okay? AB belongs to R. What does it mean? We can write A is equal to B raised to N, where N is a positive integer, okay? That is plus VE means a positive, okay? The short form of the positive word. Positive integer, N is a positive integer for the case A is equal to B raised to N. And now here we have to prove that BA does not belongs to R, okay? B comma A does not belongs to R. तो इफ सपोज के बी कोमा ए बिलोंग्स टू आर है तो उसका रिलेशन क्या होगा? सपोज के बी कोमा ए, ठीक है, आई जस्ट कंसीडर वन केस दैट इफ बी ए बिलोंग्स टू आर, तो व्हाट डज इट मीन? okay, we'll prove this for case, for this case b is equal to a raised to n, ठीक है? अगर बी ए बिलोंग्स टू आर डिफाइन होता है तो व्हाट डज इट मीन? बी कैन बी राइट एज a raised to n, clear? And if we cannot write, then what does it mean? Okay, we'll say that BA does not belongs to R, ठीक है? Where n is a positive integer here, if BA does belongs to R, suppose को define होता है वहाँ पे, तो what does it mean? B can be write as a raised to n for the case A is equal to B raised to n, ठीक है? इस फॉर्मूला में से आपको डिराइव कर सकते हो, सपोज के B is equal to A raised to n, then you can say that BA belongs to R. But let us check it, can we derive or not? If we can't derive that, then we can say that BA does not belongs to R, clear? So here BA is equal to B raised to n, that is given that. And now apply the nth root, because we need here B, there is no any power to the B there, so we just remove this n, because right now it is a power of B there. So how we can remove the n? So apply the nth root to both sides, okay? Apply the nth root, means apply nth root to both sides. So we get here a raised to 1 upon n, okay, is equal to b raised to 1 upon n into n. So what does it mean? Okay, here n will be removed. Okay, so we get only b. Clear? We get only the b. So a raised to 1 upon n is equal to b. Again, I repeat that. We have to apply the nth root both side. What is the reasons to apply the nth root both side? Because we need here b only. Why we need here b only? Because we have to check that can we write b is equal to a raised to n or not? B is equal to a raised to n or not. If it is possible, then we can say that BA belongs to R. And if it is not possible, then we can say that BA does not belongs to R. Okay. So for that, we apply the nth root here to both sides. And after applying the nth root, we get a raised to 1 upon n here. Okay. The a will be converted as a raised to 1 upon n. And b raised to n will be defined as a only b. Okay. So here we get b is equal to the a raised to 1 upon n. B is equal to a raised to 1 upon n. And when we start the example, we say that AB belongs to R, means A is equal to B raised to n, and n is a positive integer. N is a positive integer. So can we say 1 upon n is also positive integer? Yes, this is your task. Can we say 1 upon n is also positive integer? Is it a true? ठीक है, यहाँ पे फर्स्ट लाइन पे क्या था, a is equal to b raised to n, where n is a positive integer. So here we get b is equal to a raised to 1 upon n. So for this case, can we say 1 upon n is also positive integer? Is it true or not? Hello, now am I audible? So what is the answer? Question is there, if n is a positive integer, then can we say 1 upon n is also positive integer? Let's quick. What is the answer? If n is a positive integer, ठीक है, आपके पास एक integer value है n, and now consider it 1 upon n form. So can we say it is also integer? Yes, એમાં આટલું બધું વિચારવાનું હોય? હેતલ, what is the answer? રોનક, अगर n positive integer है तो can we say 1 upon n is also positive integer? Is it true? San, कैसे वो ट्रू होगा? आप बताओ मुझे। आपके पास एक पॉजिटिव इंटीजर है, इंटीजर आपको पता है क्या है? That is called z. Now check the values of z: -3, -2, -1, 0, 1, 2, 3, and so on. That is called integer value. And now consider any value from z. Let us take a 3. 3 is a positive integer. ठीक है, 3 is a positive integer. So can we say 1 upon 3 is also belongs to the z? Can we say 1 upon 3 is also belongs to z? Is it true? No, it is not true. Yes, because 1 अपन 3 वो इंटीजर ही नहीं होगा तो z में कहाँ से आएगा? ठीक है, 1 अपन n की वैल्यू हो, आप चेक करो 1 अपन 3, ठीक है, 1/2 चेक करो, 1 अपन 5 चेक करो, 1 अपन 9 चेक करो, तो आपको इंटीजर वैल्यू मिलेगी? नहीं मिलेगी। ठीक है, therefore we cannot say that is also belongs to the z. तो हमें क्या प्रूव करना था? ठीक है, टू define the antisymmetric case. If AB belongs to R, then BA does not belongs to R. तो B, A का फॉर्म क्या होगा? If BA belongs to R, then what does it mean? We'll check that B can be write A raised to n, where n is a positive integer. But when we derive this form by using the formula A is equal to B raised to n, after applying the nth root here, and we get B is equal to A raised to 1 upon n in place of n. Okay, यहाँ पे n हमें प्रूव करना था, but we get here 1 upon n, and we cannot say 1 upon n is also positive integer. Okay, we cannot say 1 upon n is also positive integer, and that required to say it is an antisymmetric relation. Okay, so therefore here you just write one line: 1 upon n is not positive integer. Okay, and therefore what does it mean? B comma A, okay, BA does not belongs to R. Okay, BA does not belongs to R, and therefore we can say it is the antisymmetric relation. Okay, therefore we can say hence R is antisymmetric relation. Okay, so that is reflexive that we discuss, and then after antisymmetric, that is a solution of antisymmetric relations. And now let us check the third one, that is the transitive. Third one is there, a transitive. So condition of transitive is there: if ABC belongs to Z, ABC belongs to Z, then if AB belongs to R, BC belongs to R, then we'll prove that A comma C also belongs to R. Okay, that is a condition of transitive. If AB belongs to R है, BC belongs to R है, then we'll say that A comma C also belongs to R. So how we can check it? Okay, let us start with these two relations. AB belongs to R and BC belongs to R. Okay, here A comma B belongs to R and B comma C belongs to R. That is a given in the relation. Means A can be write as a B raised to n for the A is equal to B, and the B can be write as a B can be write as a and B can be write as a C raised to m. Okay, because we apply the both relation at a time. So let us use the n and here m, where m comma n is a positive integer. Okay, therefore it is a valid. A is equal to B raised to n and B is equal to C raised to m. So now use this formula and prove that A comma C also belongs to R. Okay, A comma C also belongs to R. So how we can prove that? We'll apply the values of B in these equations. So A is equal to B raised to n is given that. So that can be write as a, what is the value of B? That is a C raised to m. So we can just replace the C raised to m in place of B and with the power n. And as we know that the rules of mathematics, power with power, so it convert to the product, it become here C raised to mn. What we get here? We get A is equal to C raised to mn. A is equal to C with the power m into n. And here we discuss m and n is a positive integer. Okay, both are positive integer. So we can also say that its product is also positive integer. Okay, its product is also the positive integer. M into n is also the positive integer. So that is required. Okay, and you can consider example for that. M, let us take a 5 and n, let's take a 6. Okay, so what is the product? 5 into 6 will be 30, and we can say that 30 is also positive integer. Okay, so A is equal to C raised to mn, where mn is also the positive integer. So we can say that A comma C, that is also belongs to the R. Okay, and that is a formation of AC. A can be write as a C raised to mn, where mn should be the positive integer, and here that is a valid for any case. Okay, if m and n are positive integer, then its product is also the positive integer. Okay, so A comma C belongs to R, that is approved here, and therefore we can say that R is a transitive relation on the Z. Okay, and therefore if it is reflexive, if it is antisymmetric, and if it is a transitive, we can say that ZR is the partially ordered set. We can say ZR is the O set. So is it clear, this example? Is there any doubt? So now solution is not mentioned in this PPT. So just take it screenshot for your reference how we can solve this example. Just 1 minute. This is solution of this question. Okay. So take it screenshot for your reference. Okay. This is solutions for this question. Reflexive, antisymmetric, and that is the transitive. If it is required, okay, if you can solve easily, then there is no required to take the screenshot. Okay, but this is for your reference. Done. And now take the screenshot of the second part. Okay, is it done? Is it complete? Next question is there. Prove that S60D, S60 is given that. Let us prove for the 30 first. S30D is a poset or not, and then after we'll try for the S60. S60D is the partially ordered set or not, that you have to discuss. So first S60, sorry, S30 is given that. Which number are included in the S30? Yes. How many number are included in the S30? Means answer of S30. That will be, yes. Can anyone reply? Can anyone say how we can derive the S30? Dhanraj, how we can derive S30? It's Rahul. Rahul, Vachan, Ronak. Rahul, can you hear me? Rahul?
Yes, sir.
Yes. So how we can derive S30?
No idea.
No idea. Very good. Chalo, next. Dhanraj, Umesh, Ronak. Ronak, how we can derive S30? Ronak, can you hear me? Ronak. Divisor of 30. How many numbers are the divisor of 30? Ronak, can you hear me? Ronak. Janice. Yes. Answer is there. 1, 2, 3, 5, 6, 10, 15, 30. Yes, good. That is the answer. Divisor of 30. Okay. 30 को आप किस नंबर से डिवाइड कर सकते हो? That is the solution. So you can divide by 1. You can divide it by 2. You can divide by 3. You can divide by 4. That is not true. Next number is a 5. You can divide by 5. Then after 6, 7 is not possible, 8 is not possible, 9 is not possible, directly 10. And then after 15, 11 is not possible, 12, 13, 14 not possible, 15. And the last number is there, directly 30. So this is called the divisor of S30. And that is divisor of 30, and that is known as the S30. And now relations is given that a division means for AB belongs to S30. Okay, A divide B. A R B means here it is. AB belongs to R if A divide a B. If A divide B. So which pair you can include in the relation? You can include 1 divide 3, you can include 1 divide 2, you can include 1 divide 6, you can include 1 divide 15, okay, and so on. Then after you can include 2 divide 6, 2 divide 10, 2 divide 15, 2 divide 30, but you cannot include 2 divide 5, you cannot include 2 divide 3. Why? Because 5 को आप 2 से डिवाइड नहीं कर सकते, ठीक है, 3 को भी 2 से डिवाइड नहीं कर सकते. Then after for a 3 case, third number 3, 3 divide 6, 3 divide 15, 3 divide 30, but you cannot write 3 divide 10. Clear? So that type of pair you can include in the relations, and now we'll check it is reflexive, it is antisymmetric, and it is transitive or not. So first condition is the reflexive. And what is meaning of reflexive case? For every A belongs to S30, we'll check that A comma A belongs to R or not. Okay, A comma A belongs to R or not. So here A comma A will define as A divide A. Okay, and now consider this 8 entry mentioned in this S30, 1, 2, 3, 5, 6, 10, 15, 30. We can easily say that 1 divide 1. Okay, we can easily say 2 divide 2. We can easily say 5 divide 5. Clear? That is valid. So what does it mean? So for every A belongs to S30, for every number of the given set, we can easily say that this number divide by itself means A divide A. Okay, that is a true. So what is meaning of that? We can say that D is a reflexive relation on which set is given that S30. Reflexive relation on S30. So first one is proved, and now second one is anti-symmetric condition. So for that we have, for AB belongs to R, this implies B comma A does not belongs to R. ठीक है, अगर AB belongs to R है तो B comma A does not belongs to R. ठीक है, so let us check that. Okay, here we have AB belongs to R. AB belongs to R. What does it mean? We can say A divide a B. ठीक है, तो for this two number which is A divide B, so we cannot write B is also divide A. ठीक है, we cannot write B is also divide the A. Why it is not valid? Why it is not true? Because if I consider a counter example, 5 divide of 50. Okay, 15 को आप 5 से डिवाइड कर सकते हो, that is a true. But we cannot say 15 is also divide of 5. ठीक है, we cannot say, we cannot write here means 15 can't be divide of 5. Okay, so therefore for A divide B case, we cannot say B is also divide A, means B can't be divide A. ठीक है, and that is required to say it is antisymmetric. Clear? तो अगर AB belongs to R है तो BA does not belongs to R होना चाहिए. तो यहाँ पे प्रूव हो गया, ठीक है, कि BDA that is not a valid. So therefore B comma A does not belongs to R, and therefore we can say it is antisymmetric, means D is a antisymmetric relation on S30. Clear? And now the third condition is there, transitive. How we can prove the transitive conditions? Third one is there, for A, B, C belongs to S30. If AB belongs to R, BC belongs to R, then we'll check that A comma C also belongs to R. ठीक है, A, C भी R के अंदर होना चाहिए. So let us start with these two relations because that relations we have in the example. AB belongs to R. So what does it mean? A divide B. Okay, and BC belongs to R, that you can write B divide C. If A divide B, B divide C, then based on this relations, we can say that A is also divide as C. Okay, why it is a true? Let us consider one example. 2, 6, and 30, which are belongs to S30. Okay, 2 is belongs to S30, 6 belongs to S30, and 30 belongs to S30. So 2, 6, 30. So 2 divide 6, that is a true. Okay, 2 divide a 6, that is a true. Then after we can also say 6 divide a 30. X, A divide B, B divide C. Okay, 2 divide 6, 6 divide 30. We can also say that 2 is also divide 30. Okay, A is also divide a C, means a 2 is also divide a 30, and therefore it is the transitive, and thus we can say that S30D is poset. S30D is a partially ordered set. Okay, so is it clear? Is there any doubt in this example? And this is a solution of this one, reflexive, antisymmetric, and this third one is transitive. So just take it screenshot solutions of this example if it is required. Otherwise, just consider the main point in your book, how we can prove that, and then after you can easily write. Otherwise, just take a screenshot of this page in your mobile phone, otherwise laptop. Okay, so in each example, set is different that, and the relation is also different. Okay, each and every example, set is different and relation is also different there. So we have to first identify, means we have to first verify that which number are included in the given set and what is the relations for the given set. If I consider any two number from the given set, then how we can say AB belongs to R. Okay, so condition is also different in each and every example. So as per the condition, okay, and as per the set, we can prove the example. Okay, means we can check reflexive conditions, antisymmetric, and the transitive. Okay, as per the relation. Okay, so is it done? Okay. Now next example is there. Z comma D. Is it the poset or not? Z comma D. Check that it is the poset or not. Okay, so third question is there. So पहले आप try करो, ठीक है? First prove it is reflexive, antisymmetric, and transitive. पहले आप reflexive prove करो, then we'll check the answer. It is reflexive or not, ठीक है? And then after check the antisymmetric. So here Z is given that. Okay. In this previous example, the S30 is mentioned. And now we consider for S60, S90, S25, S70, any form given in place of S30, the argument will be the same. Okay, means the proof, the data will be as it is that. Just you can change the set. In place of S60, then the set will be modified. Okay, but this conclusions will be the same, means it is also the partially ordered set. If I consider S50, okay, then this set will be modified, set will be changed, value will be changed that, but this argument will be the same. Okay, means it is also the partially ordered set. So consider any set in place of S30. If I consider S60, S90, S25, S100, S200, okay, then this set will be modified that, but the argument is that we apply in the reflexive, antisymmetric, and transitive, that will be as it is in each and every case. Okay, so therefore it is also the poset. So you can also try for S60, S90, S25, thus the same data you can put there. And now z is given here, which include the -3, -2, -1, 0, 1, 2, 3, and so on. And the relation is again the divide relation is given there. Means for AB belongs to Z, when we say AB belongs to R, if A divide a B, okay, A divide B, if AB belongs to R, if and only if A divide B. So just try it. Can we say it is reflexive or not? And when it is complete, reply your answer. It is reflexive relation, and it is easy. Okay. I need reply of each and every student. So try it. For any doubt, you can ask me. અને અત્યારે ટ્રાય કરશો તો જ ખ્યાલ આવશે કે આપણે સોલ્વ કરી શકીએ છીએ કે નહીં. ઓકે. So just try it and reply your answer. First check only reflexive relation, and then after we'll verify the answer, and then we'll check the antisymmetric. Can we say this form, this question is follow the reflexive relation? Yes, what is the answer? Is it reflexive? Rachi, can we say this relation is reflexive? Hazel, Nikhil, Fanil, can we prove this relation is reflexive or not? Yes. There is no any reply to anyone.